All right, so this is the key to topic 24, part A, worksheet 2. And so on this problem, you're dealing with the relationship between a zero and a factor. So let's look at number one. So number one, and I'm going to go ahead and write partially on this on here. So this is number one. So you're told that x equals 7 is a zero. Okay, so this is a zero. And remember, the problem wanted to know, well, if x equals 7 is a 0, then what must be a factor of this function? And all you want to, and remember, you just asked, what is a factor? Okay, so remember, when finding the 0, when we said that x equals 7 is a 0, we got this by saying this idea. So by saying that x minus 7 must equal 0, right? Because if I get x by itself, this is what I get here. So think about going backwards in the process of solving an equation. And once you get that 0 on this side, then this right here, this is your factor. So if x equals 7 is a 0, then a factor must be x minus 7. All right, so there's your answer for that one, because that's how we get that 0, by setting x minus 7 equals 0, and we get x to be 7. Number two, this time you're told that x equal negative 4 is a 0. Well, same idea, right? So if you want to find a factor, so if you're told that negative 4 is a 0, then the equation that you would get before solving would be x minus a negative 4, correct? Which, now remember, you got to rewrite this. X minus negative 4 is x plus 4 equals 0. So this part here, this is your factor that you're going to say. So if negative 4 is a 0, then a factor of your function must be x plus 4. All right, number three. This time you have a fraction. So this time x equal 3/5 is a 0. Now notice the direction said this, so keep in mind the direction says do not use fractions in your answer. So in other words, don't say, let me go ahead and write it like this. So if x equal 3/5 is a 0, then the equation would look like this, correct? X minus 3/5 equals 0. But the direction says don't use a fraction in your answer. So this is not the factor you want to say. So what you're going to do first of all is you're going to clear this fraction. So you're going to multiply both sides by 5, right? So you multiply both sides by 5, clearing the fraction. And then distributing a 5, I get 5 times x is 5x. And then 5 times a negative 3/5 is a negative 3. And then 0 times 5 is 0. So this is your factor. So the factor equals 5x minus 3. All right, so there's your factor. Okay, number 4 is another fraction for 0. So you get x equal negative 5/7 is a 0. So using that same process, if x equal negative 5/7 is a 0, then let me go ahead and kind of do this. All right, so if x equal negative 5/7 is a 0, then the equation we would use would be x plus 5/7 equals 0. So that's how, because when I solve for x, that's how I get negative 5/7. But remember, we don't want any fractions here, so you're going to multiply both sides by 7, right? And to clear the fractions. And so 7 times x is using the distributive property. 7 times x is 7x, and then 7 times 5/7 is 5. And then 0 times 7 is 0, and this is your factor. So the factor of this function has to be, one of the factors has to be 7x plus 5. Okay, all right. Now, look at number 5. So number 5 says this. Okay, so you want to write, this time you want to write a polynomial function in which the only zeros are 4 and negative 7. All right? So there are an infinite number there are an infinite number of answers you could have given here, but the only zeros had to be those two, okay? So there are two zeros here. All right, so let's think about this. So when doing number 5, the way you want to think about that is since the only zeros are, so the zeros are x equal 4 and then x equal -7, right? So if the zeros are these, then the factors of your polynomial, so I'm going to write this, factors of f of x are, all right, so if x equal 4 is a 0, then one of the factors has to be x minus 4. So there's one of your factors. The other factor, so if you're told the 0 is -7, then the other factor has to be x plus 7. So those are your factors. And so therefore f of x would equal x minus 4 times x plus 7. And it's okay to leave it like this because sometimes, especially in the next problem, you could have multiple factors. But this is easy to multiply. So f of x will equal x squared, if you use the fall method, plus 3x minus 28. So there's your one of your functions. Now, I said they're an infinite number, right? So someone else could have said, well, I'm going to just put a number in front of this. And you could have, because the zeros are still going to be those two. So in other words, you could have said -3. Oops, sorry, let me write it this way. F of x equal -3 times x minus 4 times x plus 7, right? So those zeros are still 4 and -7. Now, I want to say this. Someone else could have said this, f of x equal, and just using those two zeros, someone else could have said, well, I'm just going to say this. Watch. I'm going to say, well, I'm going to say there are, for the exponent, see how I have the exponent as x minus 4 to the first, x plus 7 to the first? Someone else could have said x plus 4 to the third power. That is true. The only zeros are 4 and -7, except there's going to, we haven't talked about multiplicity here, but technically 4 is a 0, even though you have 3 factors of x minus 4, and then -7 is a 0 with just one factor. You could have put an exponent above that one if you wanted to. You could put a number here. So there's an infinite number of answers here is what I'm trying to say. As long as the only two zeros I get are 4 and -4. There was no indication about multiplicity. So it is okay to put exponents above those factors. Okay? All right. But for the most part, almost all students will just say this. They're not going to worry about putting a number in front of this or putting exponents above the factors. All right, just make it simple, and this is what you end up with. Okay? So using that idea with number 6, let me just show you number 6. So number 6 is where you start talking about a multiplicity. All right, so remember what that means when we talk about a multiplicity. So in number 6, you're told that a 0 is x equal 3. But it has multiplicity. That zero has multiplicity 4. All right. So what that means is that this 0 occurs 4 times. All right. So if x equal 3, and that's the only 0 now, the only 0. So if x equal 3 is a 0, then the factor of this polynomial, and this is g of x, factor of g of x is x minus 3. X minus 3. And so that's the only factor you can have. You can't have any other factor except a number in front of it. So you're going to say g of x will equal x minus 3, and it has multiplicity 4, which means this, which means that you're going to have 4 factors, just like this. That's what that means. But look, an easier way, and the way you want to write this is this way. You don't want to say, if this was 40, you don't want to put this 40 times, right? So you want to say x minus 3 to the fourth power. And there's your answer. And don't multiply this out. Leave it like this. X minus 3 to the fourth power. Because if you multiply it out, which is going to take you more than 5 minutes probably. Well, no, not this one. But if you make a mistake, you're going to lose some points. So leave it like this. That's the way we leave it. Now remember though, remember I said there's an infinite number of answers, meaning that you could put a number in here. Any real number you could have put here, okay, would still be, the x equal 3 would still be a 0 with this multiplicity. Okay, so now that's the only, remember in number 3, I put 3 here. You could have put 5, you could put 8 here, doesn't matter because there was no discussion about multiplicity. Because the zeros are still, the zeros of this function or this one is still those two, okay? But for this one, you had to put a 4 because that is your multiplicity. All right, so I just want to say this, or someone else could have said g of x equal 1/2 times x minus 3 to the fourth power. So there's an infinite number of answers, okay? Because the coefficient here could be any real number. So g of x could be -4 times x minus 3. Oops, let me rewrite this. G of x could be -4 times x minus 3 to the fourth power. So here's another answer someone could have had. As long as the only zero is 3, which means the only factor involved is x minus 3, the only variable expression involved as a factor is x minus 3, because -4 is a factor if you put -4, and it has the exponent 4, okay? All right, number 7. This time in number 7, you're told this time now that -2 is a 0 with multiplicity 3, so x equal -2 is a 0, all right, but it has multiplicity 3, which means the factor x plus 2 would occur 3 times in your function. So x equal -2 occurs 3 times as a 0. And then the other one is I'm going to go ahead and leave some space here. So the other one is x equal 5 is a 0. And it has multiplicity of 2, okay? Multiplicity, it's multiplicity here of 2. So if x equal -2 is a 0, then remember one of your factors, so a factor of g of x is x plus 2. Over here, if x equal 5 is a 0, then a factor of g of x is x minus 5. All right, so using that information, we can say this: g of x will equal x plus 2 to the third power, because it occurs, a multiplicity 3 means that x plus 2 occurs as a factor 3 times. All right, and then the other one here would be x minus 5 times x minus 5 to the second power. And that's it. That would be what you would write. All right. But remember, there are an infinite number of answers you could also give, because someone else could have said, well, as long as I put a number here, I'm fine. That's another that is another polynomial with just those two zeros with these multiplicities. And that is true. Someone else could have said -1/2 times x plus 2 to the third power times x minus 5 to the second power, because the only zeros are going to be -2 and +5 with these multiplicities. All right, so there are an infinite number of answers you can give, as long as this is what I see, and you can use any other real number for your other factor. Okay, all right, so that is the key to topic 24, part A, worksheet 2.